We're talking about in this lesson antiderivatives. These are the antiderivatives f of x, g of x, and h of x of small f of x, which is equal to x cubed. So these are the antiderivatives of f of x. The capital F here, as you can see, is called the antiderivative of the function f of x, which is labeled as a small f. If capital F prime of x is equal to f of x for all x which is an element of the domain of f. If f of x and g of x are antiderivatives of some function f, then f prime of x is equal to g prime of x. And f of x is equal to g of x plus c for some constant c. Well, this all may sound pretty abstract, but let's look at an example. So here is our antiderivative of f of x. So this is how we write it. To find the antiderivative of f of x, we write it like this. This is the integral sign, this is the integrand, which is our function f of x. And as you can see here, it's equal to x cubed plus c. And you're probably wondering, how did we go from here to here? Here's the general formula, and there should be a plus c right there. I guess I left that off. Let's look at another example. So we're wanting to find the antiderivative of g of x, which is equal to 5. We want to find capital G of x. Here's our formula. Now this is a constant, and k is our constant. The integral of a constant, you're going to tack an x on and then make sure you don't leave off the c, plus c. And as you can see, the antiderivative, which is in red here, is 5x plus c. Now let's check to see if that really is the antiderivative. What we're going to do now is we're going to take the derivative, which we'll call g prime of x, and the derivative of 5x plus c is just 5. So you can always check your work. Once you take the integral of a function, you get what that integral is, take the derivative of it, and if you get back what's inside, then you know you've done it correctly. Okay, so let's look at this. We have f of x is equal to x to the fourth, and we want to find the antiderivative. And here it is. But let's show how that works. Now this is the formula here that we're going to use, and what we've got here is we've got x to the fifth over 5. This says add 1 to the exponent and then put the exponent down into the bottom. So we do that. Here's the exponent. So we add 1 to the exponent and then we put the exponent in the bottom. So this becomes x to the fifth over 5. Now remember, you can take the derivative of this, and if you get back f of x, then you know you've done it correctly. Okay, so we have f of x in this problem is equal to 4x to the 3 halves. So we're going to use this form here. Now you notice we have a 4 as a coefficient, and that's going to be our a. So what we'll want to do here is take that outside first and then go ahead and integrate. So we add 1 to the exponent, and 3 halves plus 1 gives us 5 halves. You take the exponent, put it in the bottom, and then you'll need to simplify this down. And so we're going to take this and flip it, put it in the top, multiply the 2 times the 4, which gives us 8 fifths, times x to the 5 halves plus c. So this is the antiderivative, and remember to check this, take the derivative of it, and if you get the integrand, you know you've done it correctly.